Hey, here we go. Let's talk about explicit equations for quadratic functions based on rectangles and squares. What I'm going to show you here is examples 3, 4, 5, and 6, and then I'll give you a couple to work on your own. Before we get too far into this, I would like you to go back to your notes in your graph notebook, and it was from September 15th. And we did 2 examples with rectangles and squares. And we called them example 1 and 2. And if you can't find those, I made a video that day, and it's the video rectangle examples from 9:15. And you should go if you can't find the notes on these. And example 1 starts at 8:43, and example 2 starts at 17:34. Okay, so you're either finding those 2 examples in your notes, and you'll know because they're rectangles and squares. And we wrote an explicit equation for them. And if you can't find them in your notes, then go ahead and check the video out and get those 2 examples into your notes. When you're done with that, come back and we'll move on with today's lesson. And you know there's about to be a question about it, right? All right. So we're ready. Example 3. I'll give you a second to copy this down, and I'll go ahead and tell you what it is in case it's hard to see on your screen. I have term 1, 2, and 3. Term 1 is a rectangle that has 3 on this side and 2 on top. And term 2 is actually a square. It's a 4 by 4. And term 3 is a rectangle that's 5 by 6. And we're looking for the first difference, second difference, and recursive, and then we're going to work on the explicit right after that. So I'd like you to pause the video and get these solutions, and then come back and show me what you got. Okay, if you're back, it's because you got your table, your first difference, your second difference. You wrote down your recursive, and I did f of 3. And I'm going to talk you through just this one for one more kind of chance for some help on this. I picked f of 3 to figure out the extra number. So f of 3 minus 1, well, that's f of 2. And 4n, because 4 is the second difference, plus blank. So now I substitute. F of 3 is the number 30, because it's the answer that goes with 3. F of 2 is the number 16, because it's the number that goes with 2. And it's also the previous answer. Then 4n, or 4 is the second difference, times n. We're dealing with f of 3, so 3 is our n. And then plus or minus a mystery number. So that gives me 30 equals 16 plus 12 plus 2. And, I had to do plus 2 because 16 plus 12 is 28, and I needed a plus 2 to make it equal 30. Okay? So then make sure you write your equation and box it or something so that you have a final version of your equation. Then you should try it using another number. So I tried it using f of 4. And because, of course, I figured out f of 4 from the numbers above. And when I did f of 4, it worked. So that gave me confidence in my answer. Okay, so now we're ready for the explicit. So the explicit is, it's in a lot of quadratics, it's very complicated to figure out. We're just doing examples based on rectangular numbers for now. So what this starts with is 1/2 times your second difference. And then it's based somehow on the sides of the rectangles. So this is term 1. Well, actually, let's look for our second difference. Our second difference was 4. So 1/2 of 4 is 2. So that means somehow in this equation, I know I'm going to have 2 times something. So the first thing that would be easy is to look at our terms here. I didn't fold that very well. Let's try that again. is to look at our terms and to see if any times 2 kind of pops out at us. And I can see it. I can see where a times 2 is in all of these. Because remember, x is your term number. So in this case, x equals 1. And in term 2, x equals 2. And in term 3, x equals 3. Our second difference is 4. So that means one of the numbers in our explicit, a multiplier, is going to be 2. And look, if I look across the top, I can see 2, 4, 6. So I know that my top of my rectangle can be represented by 2 times x every time. So this could be 2x. This could be 2x, because that would be 2 times 4. And this could be 2x. And then what could the other side be? It's always going to be something involving an x, usually like adding or subtracting to x. So this could be x plus 2. Oh, this could be x plus 2. This could be x plus 2. So I think I found it. I think this side always works out to be x plus 2. Now remember, x is a variable, which means it changes. So in term 1, x is 1. So this is 1 plus 2. In term 2, x is 2. So this is x plus 2. In term 3, x is 3. So 5 is x plus 2. So remember that we got the numbers in our XY table by finding the area of the rectangles. So these are all area. And remember that area is length of a rectangle is length times width, or base times height. Or just like one side times a different side. So we've got this. One of our sides is 2x. So 2, this would be an x in here. Oops, you can't see that. And then the other side would be x plus 2. So I'm going to write it like this. I'm going to put this 2 and this x together, and then x plus 2. Could you distribute it? Yes. And that's where your x squared would come from. You would get 2x squared plus 4x. We're going to leave it like this for right now, though, because we are using it to represent a rectangle. And so let's try it now. We have, this is our equation for explicit. And let's try f of 2. Let's see if our equation works. Oh, that's so many 2's. I shouldn't have picked f of 2. So that's 2. X is 2. Because if I pick f of 2, this is x. I can't believe how many 2's there are in this. And then x plus 2. So 2 times 2 is 4. Times 4 is 16. A really great thing to do right now would be to cover this up and see if you could write the explicit and try it on your own. All right, let's move on to another one. Okay, now we're going to do example 4. This is example 4, and I'm going to give you a second to copy it down, get the first difference, the second difference, and the recursive, and then if you want, go ahead and try the explicit. But we'll get these first. Okay, you're going to pause, and then you're going to come back when you have all of this. You're back. That means that you filled out the table and found the second difference. And I found term 4 by just assuming or looking at what would come next. This went 4, 6. This went 4, 6, 8. So I assume the next one would be 10. And this went 8, 10, 12. So this one would be 14. So my term 4 would be 10 by 14. Just by following the pattern. So that meant the area was 140 of that one. And then I got a second difference of 8. I always write my blank recursive first. It's just good practice. Then I love f of 3. So I stuck in f of 3. and my second difference. Then, of course, f of 2 is that. So f of 3 you already know is 96. F of 2 is 60. And then 8 times n, well, we're using 3 for n, so that's 24. And then I ended up with the mystery number of 12. So there is my equation. I should have boxed it so it's clear that that's my recursive. And then I tried it using f of 2. And you can pause and take a look at that if it doesn't match your work. And even if you didn't use f of 3, as long as you ended up with 12, it's fine. And even if you didn't try it on f of 2, as long as you tried it on a number and it worked, then you're good. So now let's talk about the explicit for this. So for the explicit, and remember, these are the explicits that really just kind of work with rectangles. And the goal here really is to get good at our geometry and to see how it relates to quadratics. So our explicit, we know it's going to have f of x. And then it's going to have 1/2 times the second difference. And then it's going to have a couple other factors here. So we know that 1/2 times our second difference is going to be 4. So we already know that we're dealing with something with 4 here, and then a couple other factors. Now, this one, I got to tell you, it's a little tough. It took me a minute, because I just thought it would be like the last one, and it could be like, oh, times 4, times 4, times 4. But it doesn't work. So there's not an easy times 4. But I know 4 is involved somehow. So I thought, you know how 4 might be involved? Remember that one we did that was the big letter I that had 7 squares in it? Well, this 4 does mean that we should be able to divide these into 4 equal rectangles. It really does mean 4 rectangles. So if I divide these into 4 rectangles, it's okay if you didn't think of this. One of those things that it's all new, right? 1, 2, 3, 4, 6. 1, 2, 3, 4, 5, 6. So now, what if I just find one of these rectangles and then just multiply it by 4? So, and the reason I knew to do that is that's 1/2 my second difference. Well, if I think, x equals 1 here, and I just look at one of these rectangles, then I think I'm going to have some options that are a little bit easier to look at. So if I just look at one of these rectangles, I've got a 4 by 2. And if I just look at one of these rectangles, I have a 3 by 5. Right, so I have a 2 by 4, a 3 by 5, and then here, this one is 4, 1, 2, 3 by 6. So what do you think if you just had this rectangle? And x equals 1, x equals 2, x equals 3. How could you express that term 1, one side is 2, term 2, one side is 3, term 3, one side is 4? What would you put for that side of the rectangle? I think it's just x plus 1, isn't it? Right? X plus 1. Just for this little one. X plus 1. X plus 1. So far, so good. What about the top? Ooh, is it 2x? Because it's like 3, 6. Nah, it doesn't work. And you know how else I know it's not 2x? I already know that my multiplier is 4. And I already have that handled. So this looks like x plus 3. Ooh, yeah, it is. Oh, I gave it away. So now, here's what we have. We have 4 rectangles that make up one big one. So that's the times 4. each individual rectangle inside is made up of x plus 1 times x plus 3. By the way, this is what I'd consider a level 4 example. So, for example, this would be probably one of the hardest problems I would ask you. And now, that's our explicit. Let's try it. Let's try, let's see if I can pick a better example than last time. Let's try f of 4. Why not? F of 4 should equal 4, and then x is 4 plus 1, and then this x is still 4 plus 3. Right? I just substituted a 4 for all my x's. And then we have to do our order of operations here. Remember PEMDAS, parentheses first. So that's times 5 and 7. And then when we multiply, we don't distribute. We just multiply these two and then these two. So that's 20 times 7 equals 140. And that is what we got for f of 4. Again, if I were you, I would pause the video and just see if I could come up with that explicit by myself, just to see if you were following what happens. Because you are about to have to do a few by yourself. That one was a little gnarly, by the way. But hopefully you also looked back at example 1 and 2 in the other video. Your assignment will be example 5. And you're going to copy that in a minute. I'll give you a chance. And then example 6. So you can take a picture of this or hit pause for example 5. And then you're also going to hit pause and look at example 6. So here's example 5. And I'm going to let you copy that. I'm going to put a little note here about example 1. Since there is no term 1 yet, you can use the explicit to find term 1 when you're done. And then you're going to copy example 6 in a second. So stop your video here and copy example 5. Or take a picture with your phone as long as you can read it. And do this in your graph notebook, of course. And then example 6. I'll even give you a couple of those. This one's a little weird too. I thought it would be fun. So go ahead and copy that. And I'm just wondering if you are going to be able to get the explicit on this one. Get as much as you can. It's a good challenge. Okay, good luck. See you tomorrow. I hope it recorded.